Good morning, roommate. Today we're going to start a new unit for language arts. That means our investigating the past book is done. You can keep reading articles from that book. You can finish reading the book. If you have time, you can read it over the summer, whatever you want to do. But we're going to actually move on to this brand new book, which you should have in your bag. So this is called Wind and Water Change Earth. This is the unit that we're starting today. And this unit is a science unit. It's got all kinds of science articles in it about how the wind and the water affect the earth. So find this book so we can start learning about wind and water changing earth. Pause the video now if you don't have what you need and go look for it. Okay, good morning. Now that we have our book, Wind and Water Change Earth, you're going to open to pages 2 and 3, and you can see here these big pictures, and we're going to just look at each of these pictures. I want you to think about what you see. What do you notice? You can talk about this with your family or siblings or cousins or whoever is in the house with you, and just talk about these pictures. Our essential question is, how do we react to changes in nature? So things happen in nature, mudslides and tornadoes and hurricanes, and here we have sometimes had forest fires. And the essential question is, what do we do as humans to react to those changes? So this unit is going to focus on how wind and water are changing the earth, but you can also think of it in a big picture about all kinds of other ways that the earth changes. So let's go ahead and read that essential question together, point to it, make sure you're ready, and go.
Essential question. How do we react to changes in nature?
Okay, so let's look here, and what do you notice here? I see in this picture, there's things happening in the sky, there's things happening here. I can see that this water is actually going underneath this part of this earth, almost like this earth has become a bridge. I wonder how that happened. This would be a good question to ask yourself, or something to think about, is how did this water travel from what looks like the ocean in the background up to this part? Why is this here? This is called like a little cove, and this would be a land bridge. This is called a land bridge. How did that happen? What do you guys think? So take a moment, think about it, make some guesses, think through. And then up here, I see something happening in the sky. I wonder how that's going to affect the earth. What's going on there? What do we call that? So looking carefully at your picture on page 2. Then we're going to scroll over to page 3. And actually, this is an example of a glacier. You can see right here is some frozen water. I wonder how frozen water is going to affect the earth. I think this is actually called the Mendenhall Glacier. It's near Alaska. I've actually been there before. This picture looks really familiar to me, although now it's melted a lot because of the way that the Earth's climate has changed. These glaciers have gone back further in between the mountains because it's too warm. The ocean is too warm. So then down here, this is a picture of some cliffs in Ireland called the Cliffs of Moher, or Moher, or Moore. I'm not sure how to pronounce it, but I've actually been right here before. I think I've stood right here on this spot and taken a picture just like this. Not this picture that's published in the magazine, but one that's pretty similar. And they're really amazing. And I'm just wondering, why are these cliffs here and we see the ocean below? How do you think the ocean is affecting those cliffs? How did those cliffs become this way? Why is the earth so far above the ocean here? When we go to the beach, we see the ocean is usually right there on the beach. So how did this happen? And these two things are very different kinds of beaches, right? You can see over here in this space, there's a beach that is, right against the water. And then on the right-hand side, you can see that against the water is a cliff face. So thinking about how these things happen and what made it looks like there used to be earth connected right here. So what happened to it? Where did the earth go? Why isn't all the land connected together? So that's what we're looking at in this unit. How is the water changing the earth, and how is the wind changing the earth? So if we go to the next page, we're going to read a couple of short selections. It might just take me a minute to get it smaller, so here we go. Okay, so we're going to read on the next page. We're going to turn to pages 4 and 5, and we're going to read this text called Volcano and this text called I Am Wind. Volcano is a informational text. It's going to give us information about volcanoes. We're going to learn something about volcanoes. And then I Am Wind is a poem. So we're going to learn, we're going to see how the poet uses this idea, I am wind, in her poetry. So let's start with this text, Volcano, on page 4. Make sure that you have your finger ready so you can follow along. And we'll go ahead and go through the short read first, just listening and following along. You can then, when I read it to you, go ahead and read with me. So first time through, just listen and follow along. And then as we read paragraph by paragraph and look closely and find important words and underline important details and add notes like we always do, then you can read along with me. Here we go.
Shared reads 1 and 2. Remember to annotate as you read.
Volcano. Under Earth's crust is a layer of large rocky plates called the mantle. These plates shift and move around. Sometimes plates push against each other with so much force that one plate slides on top of the other. This causes the mantle to melt and push up, melting even more rock. The heat and pressure build until a vent or crack opens in the crust. This causes an eruption. An erupting volcano spews hot gas, rocks, and ash. Molten rock or lava flows down the volcano, changing the landscape forever.
Okay, so that is our text Volcano. Let's go ahead and look at paragraph 1, and we want to find the most important detail from paragraph 1, underline it, and write our notes. So we're going to do that together because it's our first time checking in with this unit, and I will help guide you through it. So starting here, it says, paragraph 1, please read with me. Under Earth's crust is a layer of large rocky plates called the mantle. These plates shift and move around. So not like the plates that are in your dishwasher or in your sink or in your cabinet. These are different kinds of plates. They are called tectonic plates. That's something I'm going to show you a video about in a little bit. But under the Earth's crust, so just under the layer of the Earth, are these plates called the mantle. And they shift and move around. So we want to underline something important. And I'm going to underline rocky plates move around. And so when I write my note over here, that's the detail I want to keep. So let's go ahead and write our note down of what we need to remember from this section. Sorry, that keeps jumping around. Okay, so for paragraph 1, our text notes that we're going to write are that plates under the earth move around. This is important about volcanoes because under the earth, under those plates is some magma, and when the plates move around, the magma can go to the surface and becomes lava coming out of a volcano. So plates under the Earth's surface, meaning the top layer of the earth, move around. They are moving all the time. Not only do those plates cause volcanoes, they actually also cause volcanoes. Earthquakes. So they caused earthquakes and volcanoes. They affect our lives all the time. So don't forget to number next to it that you got this from paragraph 1 and write your note down. Now let's go ahead and look at paragraph 2 and let's find the most important details from paragraph 2. Sometimes plates push against each other with so much force that one plate slides on top of the other. When this happens, that's called an earthquake. This also causes the mantle to melt and push up, melting even more rock. The heat and pressure build until a vent or crack opens in the crust. This causes an eruption. So this is one kind of volcano. There's actually a few different kinds of volcanoes, but this particular kind of volcano, this is how it happens. So we are going to go ahead and make our note what happens. So when the plates under the earth move around, what is our important detail? First, let's underline what we learned. So go ahead and underline with me. It said sometimes plates push against each other. So I'm going to underline that part because I think that's important. Plates push against each other. They slide on top of each other. Oh, and then something melts. The mantle melts and it melts even more rock. That's what we call magma. Magma is melted rock. And a crack opens up in the crust. And then we get an eruption, a volcanic eruption. That's when lava bursts out from the ground, usually at the top of a mountain, and erupts into where we are. So that's a lot of details to think about writing down. So we want to kind of summarize that into our own words, and I'll help you with that this time. So we already have that the plates in the Earth's surface move around. So we're going to add from paragraph 2, they bump each other. And the next part, it says something melts. Well, things melt when they get hot. So I'm going to say they get hot. And I'm going to also add the next part, how they crack through the earth and they erupt. So, and crack up through the earth. Okay, so that's enough for our note because remember, we're just summarizing just the main idea of what we're learning in each section. We're not trying to write down every single part of it. Now last thing that we look at is paragraph 3, and we are looking at our important details. Don't forget, I'm going to pause at the end of this video so that you are at the end of this part of the lesson so that you can actually write down everything. I'll put a picture up so you can see all the different sections and finish copying those notes down and finish underlining if you're not keeping up right now. So don't worry, you'll have time to catch up. So looking at paragraph 3. In paragraph 3, it says, an erupting volcano spews hot gas, rocks, and ash. Molten rock or lava flows down the volcano, changing the landscape forever. So the erupting volcano has gas, rocks, and ash, and lava. So what do we want to share from here? Well, we know that it's cracking up through the earth. We know that it's erupting. So we need to make sure that we write down what comes out of the earth. So for paragraph 3, and I'm just writing it down below because I ran out of space. Paragraph 3, rocks, gases, ash, and lava come out of the earth and change the By landscape, they mean like the environment. So that's actually the word I want to use, but I don't want to write environment right now. So change the, I'm going to say habitat. No, I'm going to say environment. So that's my note for paragraph 3. Please go ahead and take a moment to pause the video, finish writing down all your notes. I will take a screenshot of this so that you can continue to copy it as I move on. If you haven't finished, pause the video and finish your work before we continue. Okay, next we are looking at page 5. I am wind. Please make sure you're on page 5. Point to the text, I am wind, and be ready to listen to this poem. Again, first time through, we're just going to listen. And then I have a little word hunt that we're going to do, which is something we've done before. So let's go ahead and listen and follow along.
Shared reads 1 and 2.
Oops.
I
There we go.
Am Wind by Constance Andrea Karemis. I am restless, never still. I know no bounds, go where I will. Free to fly, I set my course. I am wind, a mighty force. Hear me whisper, hear me moan, as I carve out shapes from stone. Round and round the rocks I go, never stopping, blow, blow, blow. Centuries is what I take for all the sculptures that I make. But at last I leave my mark for you to see at Zion Park. Towers made of rock and sand, all mine, no touch of human hand. Just an old wind passing through, but see the wondrous things I do.
So this poem is comparing, is making the wind seem like it's the one telling the poem. And this is an end rhyme poem. That means that for every 2 lines, so if you look at these 2 lines right here, oops, for every 2 lines, I am restless, never still. I know no bounds, go where I will. Well, when we're looking at those 2 lines, the words still and will rhyme. And so as you practice reading this poem through again, I want you to look for words that rhyme and go ahead and you can do like a big circle around them or underline them and when you find them. And then it also might be good to maybe draw like an arrow, a double arrow that connects them. So you're showing which of the 2 words are rhyming words. So that is something you can do. Like right here, I have still and will, and the arrow, double-sided arrow, is pointing to both words so that we know that those are the 2 that rhyme. So as you reread that, go ahead and mark each one. If you haven't finished, pause the video and finish your work before we continue. Okay, once you have found each of the rhyming pairs by looking at every 2 lines and rereading and finding the rhyming pairs, I want you to see if you can write down one more word that rhymes with the 2 words that you found. So for example, in the first section, we found that still and will are rhyming words because they both end with ill. The next thing I want you to do is think of another word that ends with ill. So put on our thinking caps, take a moment, and I can think of a word, fill, like you fill a cup of water. So, or like lava fills the crater of a volcano. So on my notes section on the right-hand side, you're going to write that rhyming word that you think of that rhymes with the words that you found. The next 2 set of words, course and force, you're going to try to think of another word that rhymes with those. Now, it doesn't have to be spelled the same because we're looking for the same sound. Course and force, you'll notice that course ends with SE and force ends with CE. And you'll also notice that the vowel pattern in course is OU and the vowel pattern in force is a bossy R. So they are very different spellings, but they sound the same. So thinking of another word that rhymes with course and force. Oh, something you ride. That's your clue. Go ahead and make sure that you write down in your notes a list of words. You should have 1, 2, 3, 4, 5, 6, 7, 8 words listed in your notes section next to the poem, I Am Wind. When you're done, pause the video so that you can finish your work. Okay, next I want us to look at some vocabulary that's going to help us with this unit. Our first vocabulary word is the word canyon. Everyone say with me, canyon. You can see the syllables broken up down below, canyon. Here's a couple sentences to help us remember the word canyon. So these are pictures of the Grand Canyon, which is the largest canyon in the world. So it says, the canyon is large. Read that with me. The canyon is large. The next one, the canyon is deep. Read it with me. The canyon is deep. Another important vocabulary word for this unit is the word erosion. So here's our pronunciation, erosion. S-I-O-N in this word is saying jeune. So let's read the sentence. The water caused erosion. Read it with me. The water caused erosion. You can see the water flowing on the bottom of the canyon, and actually the water is what created the canyon in this case. The water wore down the sand as it flowed, and it kept wearing it down, and the cliffs got taller as the water went deeper into the earth, and that is called erosion. The other thing that causes erosion is the wind. The wind causes erosion. The wind can blow against the sand and make the sand blow against the rocks. And just like when you're doing sandblasting to clean something, it causes erosion. It breaks the rocks up into more sand particles. So let's read that sentence. The wind caused erosion. Next vocabulary word that's going to be important for this unit is the word mudslide. Mudslide. This is a compound word. It's the word mud plus the word slide, and it means exactly what it sounds like. Mud, sliding down a hill or sliding off of a cliff. Let's read this sentence. This is a mudslide. Read it one more time for the next picture. This is a mudslide. Hope you're reading along. Next word is visit. Everyone say visit. They visit the canyon. Read the next one. They visit the canyon. So they can visit the canyon on horses, or they can visit the canyon by hiking. And look at these people are taking photographs. Our next vocabulary word is actually that's it. Sorry. Those are all of our vocabulary words. So For our vocabulary this week, let's practice those words one more time. Canyon, erosion, mudslide, and visit. Stay tuned for some bonus content.
Hi, it's Doug. What counts as a mountain? Would you call this a mountain or just a hill? For me, growing up, I thought of this as a mountain. But that's probably because I grew up in northern Illinois, one of the flattest places in the world. And this thing, this hill, I guess, is one of the tallest things around. Turns out the only reason it's there is because it's the old landfill. It's a hill made out of garbage. Someone named Sophia has a question about actual mountains. Let's give her a call now.
Hi, Doug.
Hi, Sophia.
I have a question for you. Could a mountain turn into a volcano?
Ooh, that's a great question. Could a mountain turn into a volcano? If you're thinking, no way, here's a true story that might change your mind. Heimaey is a little island just off the coast of the country of Iceland. A few thousand people live there and call it home. The island of Heimaey is actually a mountain. If you were to sail up close to it, it may look more like a hill from the side. But when you include all the part of it that's under the ocean, you can see that the part sticking out of the water is the top of the mountain. One day, in the year 1973, the people living on Heimaey got the surprise of their lives. A crack had formed on one side of the island. Lava was spurting out. The residents of the island were evacuated to safety on nearby Iceland. The eruption lasted for nearly 6 months. Finally, the lava cooled off and had become solid rock, volcanic rock called basalt, rock that's dark in color and extremely tough. The island of Heimaey had gotten bigger. So it seems like here's a case where a mountain did turn into a volcano, at least for a few months. Now, to be fair, I didn't tell you much about the original part of Heimaey, the part people had been living on. It's made of basalt too. Technically, Heimaey had always been a volcano. It's just that it hadn't erupted in a very long time. And so the people of Heimaey were a little surprised. But it does make you wonder, could any old mountain suddenly turn into a volcano and start erupting lava? I live in the US state of California, just a few hours south of the state of Oregon and Washington. And anytime I drive around in any of these places, I'm always amazed at how many of the mountains here are actually volcanoes. Quiet, peaceful-looking Mount Lassen in Northern California, it erupted 100 years ago, back in 1915. Beautiful Mount St. Helens in Washington, it blew off half its top back in 1980. And it's the same thing for so many other mountains in this area. Mount Rainier, which towers above the city of Seattle, it's a volcano. Mount Hood in Oregon, volcano. Even little mountains, like this one called Black Butte, along the side of the road in Northern California. It's a volcano. When you see so many mountains that are volcanoes, it gets tempting to think, well, is every mountain a volcano? How do we even find out? Like, would you just have to wait for it to erupt lava to find out? But surely not. Let's say there's a mountain near where you live. What do you think? How could you find out if it's a volcano? What are some clues you could look for?
Okay, take a moment and think, what could you look for to find out if one of our mountains is actually a volcano? What would you look for? How could you figure that out? I'm going to pause the video for a moment and I want you to think about it and share some ideas with someone if you're in your house if you can. Okay.
You might have had different ideas. Maybe you thought to feel it, see if it feels hot. Here's another possibility. Look at what kind of rock the mountain is made of. If it's volcanic rock, then there's at least some chance that the mountain might have the ability to erupt lava. You can get good at learning what volcanic rock looks like. I mentioned basalt earlier. It's one of the most common kinds of rocks that volcanoes are made of. It's always dark in color and really tough. This is rock that doesn't crumble easily. Some basalt even has little holes in it, like this. Those are air bubbles from when it was still lava. If you go out and look at what kind of rock different mountains are made of, you'll discover for yourself that not all mountains are made of volcanic rock. For example, check out the red rocks of Colorado's Front Range, the east edge of the Rocky Mountains. They're made of a reddish colored sand and bits of pebbles that formed along the bottom of a river. Or even Mount Everest in Asia, the tallest mountain in the world. Now, if there's any mountain that might be a huge volcano, it's tempting to think this has to be it. But climbers who've made it all the way to the top can tell you that a lot of the rock up there contains fossils of animals that lived along the bottom of the ocean. Up on top of Mount Everest, there's rock made of sand, pebbles, coral even. There's no volcanic rock at all. Mount Everest has never erupted, and there's no reason to think it ever would. It's not volcanic. Still, you might be surprised to find some mountains made of volcanic rock, even if you live somewhere that's not ever been known for having volcanoes. Like here in the US state of Missouri, for example. Thousands of miles from any famous volcanoes are the St. Francis Mountains. The tallest peak, called Tom Sock, was a volcano that spewed out lava, which cooled off and became volcanic rock. Or in the US state of Virginia are two small mountains. Maybe we should just call these hills. But both of them are made of basalt. Where did that come from? Not every volcano is an active volcano. All of these examples are extinct volcanoes, volcanoes that erupted an extremely long time ago and so left behind volcanic rock, but which haven't erupted since, and scientists think are really unlikely to erupt again. So in summary, most mountains won't just erupt lava out of nowhere. If they do, it's usually because there's been eruptions in the past. While not every mountain is a volcano, a lot of them are, sometimes extinct volcanoes of the past. You can look for clues by searching for volcanic rock. That's all for this week's question. Thanks, Sophia, for asking it. Before you vote on next week's question, we put together some amazing visuals that we'd love to show you. Take a look inside, or if you don't have time, you can skip straight to voting.
Here are some volcanic pictures that we're going to look at.
Number 5.
says, when an animal or person bumps into this plant, it seems to explode. How could exploding help this plant? You should think back to all of our lessons about seeds that we were doing just before we stopped going to school every day. Look what happens. What comes out of it? Why would it help the plant to shoot all those things out when it broke off from its stem? I wonder. Let's look at the next thing. It says the black things are seeds. When the plant explodes, it spreads its seeds everywhere, which will hopefully grow into new plants. So not just volcanoes explode, lots of things explode in nature.
Number 4.
Let's read this. So what is this animal and why is it doing a handstand? Hint, its black and white colors might give you a clue. Now this animal doesn't look the same as the ones I've seen in California, but maybe you've seen one of these animals around. I would avoid this animal if I were you because I think it might be a skunk. It says, this is a type of skunk. When it's scared, it does a handstand to look bigger and is a warning to go away. Otherwise, it will spray. And it's,
Number 3.
There we go. If a bird attacks this gecko, the gecko can do something amazing to defend itself. What do you think it will do? It can shoot a sticky, smelly liquid from little openings in its tail. It's called a golden tail gecko, and it lives in Australia.
Number 2.
This fish can spit water into the air. It's amazing, but why does it do this? How could spitting water help this fish? Let's see. The archer fish shoots water to knock bugs off of plants. When the bug falls into the water, they become lunch. Look at that. So there's a little bug up there in the pink circle. And now it's going to fall into the water. And chomp, fish eats it. That's a pretty weird fish.
And now the last one.
This snake is a special kind of cobra. Check it out. What do you think it's spraying? Spit? Water? Something else? What's coming out of its mouth? Whew. It's spitting venom, which can be deadly, out of its 2 front teeth. Here, scientists are seeing how well it can aim at the sheets. So they're moving those sheets around and they're seeing if the cobras are able to aim directly at them. And it looks like they're doing a pretty good job of hitting the plastic sheets. So they're pretty accurate. I would not want to meet that kind of cobra. Okay, great job today. I hope you enjoyed our lesson.
Now for the next episode.
I hope you enjoyed our lessons about volcanoes and the bonus content about some really strange animals that have things and plants that things explode out of. I'm hoping you're having a great week. Stay tuned later today to find your math lesson and look for more videos about volcanoes online. Do some extra research. Learn about how volcanoes are formed. There's some great videos on National Geographic that you can check out. And I'm sure there's lots of great videos on the internet about volcanoes. Just ask your parents for help to find some that are safe because I don't want you to see something you shouldn't. Have a great day. That's it for our language, arts, and science lesson.